So much fantastic technology that we just saw on this webinar until this point. Let's wrap it up with a success story from an important corporate account in North America. To talk about this success, I have with us our colleague, Jim Jackson from America. Hi, Jim.
Good morning, Miguel, and welcome everybody.
Yes, good. It's good to have you here with us, and thanks for being here with us. So, Jim, talk to us a little bit about John Crane.
Great. The project I'm going to be showcasing today is from a company called John Crane. John Crane is a global company with manufacturing facilities worldwide. They're headquartered in Chicago, and they're part of the Smith Group. They provide engineered solutions to the process industry. I have been personally involved with John Crane since 2002. I have seen their journey. In 2002, they moved away from their language-based CAM system called Compact 2, and they went to a more graphical CAM solution, and they selected Edgecam. So they've been working with Edgecam for the last 19 years. John Crane was like everybody else during that time frame. Everything was programmed using 2D geometry, wireframe geometry, stick geometry, whatever you want to call it. It was all manual programming. Very little automation, and where the automation was, it was always with wireframe geometry. It was about 4 or 5 years ago that John Crane started investigating and discovering the advantages of integration between CAD and CAM. They have Solid Edge as their global CAD solution and Edgecam as their global CAM system. Some of the key factors that they discovered during this investigation is that they have the attributes on the solids. They're there. Use them. We want to eventually eliminate their need for prints. We want to go paperless. Keep the design intent. Consistency. They want to be consistent in their programming, thus eliminating costs on the shop floor, whether it be direct or indirect. The John Crane vision is, how far can we take intelligent automation? They want to be on the cutting edge of technology. They want to push the boundaries. It's not just their CAD and their CAM, but they're also machine tools and their tooling. Here's some examples of the sleeve family, sleeve product line that they want to have an automation project for. If you notice that these sleeves are thin wall sleeves, they can be up to 8.5 inches in diameter and 12 inches long. Thin wall sleeves create very interesting cutting conditions. You introduce vibration, and when you have vibration, you introduce chatter. The way you remove material is so key with these thin wall sleeves. So when we sat down with them to discuss this latest project and start gathering the information, we found out that they wanted us to create a rules-based, feature-based automation project for this sleeve product line. We were to use their proven methods. It must be flexible, it must be scalable, and it must be global. When we talk about their overview and some of the notes that we take, we found out that every sleeve is custom ordered. There's no stock sleeves. They programmed last year over 1,500 distinct sleeves with 6 programmers. You do the math. Their lot sizes are just 1 to 2 pieces. Their bearing bore diameters and their tolerancing is plus 1,000 minus 0. Very, very tight. The material product mix is pretty much 85% stainless steel and 15% super alloy. So we're introducing Inconel and Castalloy, some nasty material to machine.
Yes, I can imagine.
So for their expected outcome and what they're basing their ROI on, we needed to reduce their programming time from hours to 15 minutes, decrease their on-machine cycle time by 50%. They have an acronym called NRFT, do it right the first time. And we're going to accomplish this by adding additional gauge passes, spring passes, and finishing passes. They want to put the stock in, take a finished part out. And any unsupported features, new things that engineering introduces, we needed a way to notify and message the programmer that there are situations out there and features that they had to address manually. For their expected functionality, we had to automatically select their stock. We needed to synchronize the main and sub-spindle toolpath, part transfers. Everything had to be automated. OD grooving, ID grooving, face grooving, helical drilling, balance turning. And we introduced something brand new, PMI data.
So Jim, it sounds like this entire project was much more than providing CAM software. It was about understanding the entire workflow and most importantly, connecting with all the left and right parts of the flow vis-a-vis the CAD model that has intelligent information on it had to be read inside the CAM automatically and then output and see code that is intelligent and ready for the machine.
That is correct, Miguel. We are harvesting the attributes that are associated to the feature, and this also includes PMI data. And if you're not familiar with PMI, that means product manufacturing information. We are now bringing in tolerancing. We can find out where tight tolerances are, and then we can make intelligent manufacturing decisions based off that information.
Right.
Surface finishes. We can now change our speeds and feeds automatically, no more manually. That's all part of PMI data and this project.
Jim, so you've been showing us some fantastic technology and how Edgecam can help our customers, and in this case, John Crane, be much more automated, be much more driven by the automation of our system. What is the bottom line? What is the final result that we achieved at this customer?
Good question, Miguel. In less than 5 minutes, the part is machined and G and M codes are already created. Edit-free G codes and M codes. From a success rate, how did we do? So far, we have decreased their cutting time by over 48%, programming time by over 50%. We've had dramatic quality improvement. Scrap has gone down immensely. The biggest thing is their payback on their ROI, on their case study, is 6 months. They've already paid for it. That is the bottom line. They are successful. It is a proven good project.
Ladies and gentlemen, Jim Jackson from America and the case study with John Crane. Thank you, Jim.
Thank you, Miguel.